All right, let's go through this warm up. I'm actually recording. I'm recording right now. Hope that doesn't make you nervous. Okay. All right. Is it a new mic? No, it's an old mic. I just put tape on it to keep it together. Is that what you're noticing? The tape on it?
Maybe.
Oh, because new mics don't come with tape usually, but new rolls of tape do. That'd be weird if a new roll of tape had like a microphone on it. Is that old roll of tape? Yeah, put a microphone on it. All right, good conversation. Sweet. Okay, we have a piecewise function. It's a three-headed puppy dog, and it's part line, a single dot, and part quadratic. So to the left of one, it's the line with a negative slope. It's defined to be the point 1, negative 1, and then to the right of one, it's the parabola opening up. Is it continuous or not? Well, we have to run through the three-step definition, which is basically road, bridge, road. So if you don't have to number it, but if you want to do it in that sequence, the limit as x goes to 1 from the left of f of x. Okay, so you'll need all of that. The x approaching 1 from the left has to be written underneath the limit. You need f of x there. And to compute that, how do we compute that? Because I saw you did it. Plug in 1. Down here? Oh, the top. Good, because left of is less than. So you plug in a 1, you get 2 minus 1, which is 1. Sweet. So there's a road coming in. That's important. And then y'all probably did f of 1 next. Which one do we use for f of 1? The middle. And there's really, it says, use negative 1. So now do we have to do anything else? No. Okay, everything's labeled. We could just say no. You don't have to say no, f is not continuous at x equals 1, but you could. But in this case, the question specifically said, is it continuous at x equals 1? So you could just say no. That answers the question. But then you need the reason, and I like the word since, because it's fun to say, since. But you can also say because. And what's the reason? Because negative 1. Yeah, because 1 does not equal negative 1. Now here's a follow-up question. Does the limit still exist? Or what type of discontinuity do we have? Is it a jump? Is it a hole? We don't know yet, right? Like that billboard downstairs says. I don't know yet, the power of yet, okay? The power of yet. What do we need to be able to figure that out? I was just copied. I don't like dab, ever. That was like the only time I've dabbed. Well, I've dabbed once for my daughter. She said, Dad, don't ever dab again. If I dabbed too often, she'd call me Dabby instead of Daddy. And that would be an unfair nickname. But yeah, no, the power of yet. What do we need to figure out and this is recording. What do we need to determine the type of discontinuity? The limit from the right. Good. So the limit, we'll just throw it in here. The limit as x goes to 1 from the right of f of x. And which piece do we use for that? Bottom. Right of is greater than. You plug in a 1, you get 3 minus 2, which is 1. Aha. So now, can we say anything, or what can we say about the general limit? It exists. And it's 1, right? Because remember, the theorem said if the limit from the left equals the limit from the right, in this case they're both 1, then the general limit exists and it's that same value. So we do have a what there? Hole. Excellent. You have the graph coming in. This is not what the graph looks like curve-wise, but at x equals 1, you have the limit coming in from left and right to be 1, and the y value is just below the hole. Okay? So again, this is not a jump discontinuity, because it's only a jump if you have to jump to another road. We're on the same road here, so it's a removable point discontinuity. Very good. Okay, so now we're going to example 9, and example 9 is a little bit more fun. You still have a three-headed piecewise function, but it's a little more interesting because now we have not just x as the variable, we have variables that are a and b. And the instructions are telling you to find the values of a and b. So these are just some constants, such that the function f of x is continuous at negative 1. Okay, so let's look at the three pieces. We got a parabola, a point again, and a line. And it looks like if a is positive or negative, we'll have a parabola that opens up or down. And then whether a is positive or negative down here, we'll have a line that has an increasing or decreasing characteristic. How would we start something like this? We want it to be continuous at negative 1. Did you just dab? Same thing. Right. Okay. That's good practice to cough into your, what do they call that? Inner elbow. Yeah. Yeah. That got popular during 2009 when the swine flu was going around. People used to just cough like this and sneeze. No, you got to do it like this now. Okay? And then the swine flu went away, so it worked. Yeah. Yeah. But it did create several dance moves. The dab and the hold your nose, which never caught on. Will the three-step definition of continuity work here? No? No? Then what can we do? Should we graph it in our calculator? I don't even know how to do that. There's too many unknowns, right? Guess what? You can use the three-step definition because it gives you the three criteria that have to be met in order for it to be continuous, right? So let's just kind of go through it like we just did on the warm-up. We'll take the limit as x approaches -1 from the left of the function's name is f. And which piece do we use for that? The top one again. You have to be careful. Sometimes I'm kind of insidious, and I might put the greater than at the top and the less than in the bottom. These three pieces could be shuffled in any order. So don't always assume that they're listed from top to bottom as it is from left to right. But less than is good. All right, so I'll use -1 for x. I'll plug it in. -1 squared is 1 times a is a, so you're left with what? A minus b. Yeah. So that's the limit from the left, a minus b. If we knew what a and b were, that would be a number. We'd have it. But we don't know what they are. And then we have the bridge, f of -1. And just like the warm-up we had, it's the middle piece. It's 4. And then the limit as x approaches -1 from the right-hand side of f of x. Once again, to the right of is greater than, and direct substitution works. So if you plug in a -1 for x, you get -2a plus b. Now, we can't make any claim whether it's continuous or not. Instead, the instructions say force it to be continuous. So if it is going to be continuous, what do we know about all three of those quantities? They're the same, right? And they have to equal what? 4. So this is nice. We actually have a target. They all have to equal each other, and they all have to equal 4. So what you could do is say, okay, a minus b has to equal 4, and -2a plus b has to equal 4. And I'm going to put a little bracer on there because now you're like back in algebra what? 1. Very good. You have a system of linear equations. A system of linear equations. And you can solve them by guess and check, which might take a while, substitution, elimination method, augmented matrices, matrix multiplication, Cramer's rule. Remember all that? Ask Jeeves. Anyone use that website, web search anymore? Ask Jeeves? No. Okay. Google. How do you want to solve this? If I were to use substitution, I would probably solve the top one for a. A equals b plus 4, plug it into the second one, and go from there. But if you notice, the b's are already opposite coefficients, right? And so the elimination method, which basically says you can add or subtract any multiple of one equation to any multiple of the other equation without changing the solutions. The goal is to try and get the coefficients of one of the variables to be opposite. The b's already are, so you can just add vertically. So 1a minus 2a is -a. Negative b plus b is 0. There they are. They're eliminated. 4 plus 4 is 8. So if -8 equals 8, a must equal -8. And there's one of them. So what we know then is our parabola does open down based upon that, and the slope of the line is negative, right? -16. But now we need to find b. So how do we find b? Plug it in, right. You can plug it back into either one of the original. They both work. I'll probably choose the top one just because the coefficients look a little friendlier. So you're going to have -8 minus b equals 4, and so b would equal -12. Now, for a problem like this, you're essentially done because you found A and B, and that's all it asks you to do. If you box an answer, that makes it stand out, and it actually trumps everything else. If you don't box an answer, then when you work vertically like you should, the very bottom line counts as your final answer. But if you have a bottom line and you write something off to the side and you box it, it kind of trumps the bottom line. That's how College Board will look at your free response work. So in this case, I just got them both boxed because I want to draw attention to those two answers. This type of question makes a good multiple choice question on an exam. Thank you. But instead of asking you for both A and B, I might just ask you for A, or I might ask you just for B, or I might say, what is the value of A times B? What would the value of A times B here? You would have to do it without a calculator. What's A times B? That would be a great answer choice. Thanks for the idea. Without a calculator, you could go up to the side and do like stack multiplication. 96. There you go. 96. But 72 is a great answer choice. In fact, answer choice A is not going to be 72. And of course, answer choice C, which is always the right answer, will be 96. The way I would do that is just to make you do like one more thing when you think you're done with the problem. And it's actually less typing for me as well, because I can just type in one number instead of two. Okay, you think you got that? You go through the motion, step 1, step 2, step 3, and then you just force them to equal each other. I think there's a couple in the worksheet like this, and then there's, well, yeah, they might be, yeah, this one's a good one, because this one has two unknowns. Sometimes they might just have one unknown, in which case they're a little bit easier. So, any questions on this one? Continuity. You can use the three-step definition to test and also to force something, to find values. Okay, so kind of getting back to what we did when we first started using the three-step definition. We used known continuity of a function to find the limit, right? So here's the upshot of the three-step definition. If a function is continuous at a point, then the function value and the limit value are identical. And you have a lot of experience with particular functions from Algebra 1 and 2, and you know where, in fact, they're continuous, right? Polynomials, sine, cosine, and exponential are continuous where? Where are polynomial, sine, cosine, and exponential functions continuous? It's the same answer for all of them and each of them. All real numbers, right? All real numbers. There isn't a single x value where those functions are not continuous. So what that means is, at any point in the whole wide world, if you're trying to find the limit of a polynomial, a sine, a cosine function, or an exponential function, you can actually just find the what, which is easier. The function value. If it asks you to find the limit, you can find the function value because you know they're one and the same because the function's continuous. Even functions like this. I know you all know what this looks like. The natural log of x. Its domain is not all real numbers. What is the domain of the natural log of x? I know you looked at the appendices on Corpy's World and you kind of brushed up on your parent function. What's that? The domain? Anything greater than, not 1. It crosses the x-axis at 1. Yeah, anything greater than 0. Remember, the natural log of 1 is 0. That's the x-intercept. So if you take a log of anything between 0 and 1, it's a negative number. Take the log of anything greater than 1, it's a positive number. But the domain is everything greater than 0. So it's not continuous for all real numbers, but it is continuous over its domain, which means it's continuous where? For all x greater than 0. Okay? So let's try out example 10. It says evaluate each of the following limits. The limit as x goes to 1 of, oh my goodness, that looks intimidating. How are you going to find the limit of a function like that? What family does that belong to? I heard it, polynomials. It's a fifth degree polynomial. This function is continuous where? All real numbers. Is 1 a real number? Yes. Is 11 a real number? No. But we're not approaching 11, we're approaching 1. So the limit is the function value. So to evaluate the limit, all we have to do is use what? Direct substitution. Yeah. So you plug it in, you get 4 minus 7 plus 3 minus 1 plus 1 minus 5. And now is a good point as any to talk about the difference between a free response question and a multiple choice question on the AP exam. I'll test you in both of those, each and every test you take. On a free response, like this might show up as one part of a free response. This is a numeric answer. It's certainly not simplified, but it's a number. And guess what? On the AP exam, you do not have to simplify exact numbers on the free response. So you could just walk away right there on a free response and get full credit. Yeah, kind of saves some time. But again, if this were a multiple choice question, this would not be an answer choice. So then you have to know actually how to do the math. So go ahead and do the math, and you're going to get a negative 22, right? Let's say it was a free response, and I have the right answer up here. And I was like, you know what, I got some extra time. I'm not real good with negative numbers, but I got some extra time, so I'm just going to add them up, and I put negative 22, which is actually wrong. Thanks for trusting me, though. Thanks for trusting me. Y'all were trusting me. You put it down. Here's the point I was trying to make. This is correct. This is not correct. On an AP exam, do you think they'll be like, oh, they had it up here, so I just want to get that. No. If you have the right answer and you proceed past the point where you're not even required to, it has to be correct. Otherwise, you lose the point that you previously banked, which means you didn't really bank it, okay? Negative 5. Yeah, there you woo. Okay, that makes more sense. Yeah, you got a 0 plus a 0 minus 5. Okay, now if this were a free response and you go to negative 5, they're like, you had it right here. Ooh, you still have it, but you live on the edge. I like it. I like it. Bonus points. No, you don't get bonus points. You don't get bonus points. All right, here's what I want you to do. Letters B and C, I want you to evaluate and simplify both of those limits on your own without me. I didn't notice, but did Mr. Falcone have a really hard time choosing where to sit? So many options here. Did he climb over the desk? I don't know. Hey, look at that. I don't want to brag, y'all, but I just got a GLOW award from Mr. Falcone. Okay. He wasn't even here to see the dab. He just said NB is the place to be. Keep being part of NB. Thanks for all you do. Love, Falcone. All right. You know, he's a math teacher. He has his former math experience. All right, so here we go. Letter B, cosine. Where's cosine continuous? It's actually continuous for all real numbers. So the limit value is the same as the function value. So cosine of 5/3, just plug it in. Free response, you think you could stop here? Is this an exact answer? Yes. On the AP exam, you could stop right there. That's an exact answer. But you think that's going to be the multiple choice answer? No. So now you need to go to the unit circle. Cosine of 5/3 is? One half. There is no f of x, so don't just throw it in there at the end. Just work straight down. Okay? You work straight down. This equals this equals this. You're done. Okay? These are expressions, not equations. You're evaluating this one. Direct sub, natural log of e over 2. We already said that this function is continuous greater than 0. What's the value of e? Not like in Scrabble, but in math. 2.718. That's close enough, yeah. But it's greater than 0, right? So direct sub, is this then an exact answer for a free response? Yes, stop right there if it's free response. Bank the points. But on multiple choice, you got to keep going. What is the natural log of e? 1. Good. So this answer is also 1/2. Yeah. You need to know the natural log of 1 is 0. The natural log of e is 1. The natural log of e squared is 2, so on and so forth. The natural log of e cubed is 3. This is really the natural log of e to the first. This is really natural log of e to the 0. E to the 0 is 1. So it's really the same pattern. But yeah, the answer is 1/2. And I think the bell is going to ring here very shortly, so we'll stop right there with example 10. You should be chipping away at that worksheet. We will probably finish on Tuesday, I'm guessing. So we're looking like a Wednesday due date for the worksheet and a Wednesday quiz as well, okay, over math content. Have a great weekend.